The notes might be mislabeled, so make sure that these say 7.2 Dividing Polynomials. And we have these different rules that we're going to learn for how to divide polynomials. In the last section, we multiplied or raised different polynomials to different powers, and we saw all sorts of different things there. Well, let's take a look at those rules a little bit later, and let's first deal with some quick notes on division by zero. Well, I'm jumping around in these notes, so make sure you tag along with where this went. So let's think of having some sort of x table and a y table. But y is equal to 1 over x. And let's look at what happens when we get closer and closer to 0. So let's say I take the value of 1,000. If I plug 1,000 in to x, then I have 1 divided by 1,000, which I can type into my calculator if I want to see this. But it would be 1,000th, so that means I am 0.001. Because I'm taking something, I'm breaking up into very, very small pieces. So now let's walk closer towards 0 from 1,000. Let's do 100. Well, 100 would be 1 over 100, which is the same as 1 out of 100 pennies, so I'm going to write this as a decimal, 0.01. Then I can write 10. Well, that's a tenth, so that's 0.1. So I'm kind of getting closer by a factor of 10 every time. Well, let's try 1. Well, 1 divided by 1 is 1. Let's get even closer to 0. I'm getting way closer to 0, but I can still get closer than 1. Well, what if I did 1/10, which I know is the same as 0.1. So I'm going to plug 0.1 into this, and I'm going to use my calculator if I want, but I'll do 1 divided by 0.1, and instead suddenly I have 10. I could also be like, well, 1 divided by 1/10, I could multiply both parts by 10 so that this fraction goes away so that I can see where 10 came from. So 1 divided by 1/10 gives me 10. What about 1/100th? Well, then I divide by that and I get 100. So I'm getting closer to 0. So I have 1 divided by 1,000 next, and I get 1,000. So every time I get closer and closer to x approaching 0, I get longer and longer numbers in this direction. And so as I approach 0, I'm actually coming up and exploding my fraction towards infinity. I'm getting an infinitely large number. Now, only imagine this for a moment. Well, now actually draw this as a graph. Sketch a graph. When I plugged in 1, I got 1. When I plugged in 10, I got 1/10. And when I plugged in 100 and so on, I got closer and closer to 0 in my results. But when I got closer and closer to 0, I'm exploding towards infinity. So as I divide by x, that takes on this appearance. Now let's say I'm walking from the negative direction, like I'm actually approaching 0 from the negative side. Then everything I graphed would just be flipped and in this direction. But this really helps me see that as I approach 0 from the right and I approach from the left, that division by 0 is not a possibility. It explodes towards infinity. So whenever you have something, I want you to make a note of this. 1 over 0 is undefined. undefined. There is no solution to that. What you can think about is an egg. And I'm pointing this out because imagine a table, and this table represents our fraction. If I put the egg on top of the table, then that egg is not going to roll and crack. So this 0 divided by 1 is totally okay. we will not have a cracked egg. But if I flip it and I have a 0 beneath the table, then this egg is going to fall and it's going to crack, and then I'm going to have a yolk spilled out. That is just a kind of silly way to remember that 1 divided by 0 is undefined, while 0 divided by 1 is absolutely okay. So just note you cannot divide by 0. It is impossible. Let's talk about another abstract concept. Here's some quick notes on repeated multiplication versus division. Don't write this down, but way back in the day, if I wanted to take 2 and add 2 a bunch of times, it would be really boring to have to add 2 100 times. So repeated addition, meaning I'm doing addition again and again and again and again, could be represented by multiplication. So maybe that's 100. And I'm reminding you of this because when we did exponents, now I do want you to write this, 2 times 2 times 2 times 2 times 2 has to be written a certain way. Well, that would be 2 to the 5th power. So a positive exponent is repeated multiplication. You can either write that word out or just to the time symbol. But now let's talk about what I would have to do if I took a value like 1 and instead divided it by 2. But not just once, again and again and again and again, like repeatedly. Well, that means I'm taking a value like 1 and I'm going to divide it by 2 5 times. But I can represent repeated division through the use of a negative exponent. So if I have 1 times 2 to the negative 5th, then this tells you that a negative exponent is repeated division. And what's clear to me as I write this, and I'm being taught this by a teacher, is that 1 divided by 2 5 times can also be written as 1 divided by 2 5 times with a negative exponent. So the interesting thing is negative exponents do not equal negative numbers. It's very different. Now these are some rich concepts between division by 0 and then seeing a negative exponent as something new. So if you have to pause this and rewatch it or come talk to me, that's absolutely understandable. But let's fill in these rules with some of that understanding right now. If I have, in the bottom I'll show a basic example. So let's say I'm taking the quotient, meaning division, of something like 2 to the 3rd power divided by something like 2 to the 2nd power. What that means is that in the numerator I'll have 2 times 2 times 2, and then in the denominator I'll have 2 times 2. So it appears that there's 3 up top and 2 down below, so there's 1 more up top than what's below. So it looks like I could just subtract these two numbers and I'd be good to go. So when I write this with just the abstract representation of it, a to the power of m, that's the power part, divided by a to the power of n, so that division is the quotient part, I can just take the number up top and subtract the number below, and I'll be left with a rule for this. What if instead I had the power of a quotient? Well, what this means is that if I have a divided by b, so here I'm going to have different values. In this they had to agree. So I'm taking something that's being divided by something else, and I am raising it to a power. I'm replacing this with real numbers. Then the top part's going to get multiplied by itself 4 times, and then the denominator is going to be multiplied by itself 4 times. So if I have the power of a quotient then I can just attach that exponent to the numerator's value as well as the denominator's value. Now let's talk about the 0 exponent. You've seen this before, that anything raised to the 0 power is just 1. So instead of showing it with the value of 5, I'll replace it with a, which is the common representation of the base of an exponent, and a to the 0 power is 1. I think I talked to this at length here, so for the negative exponents, I'm not going to continue that explanation. Instead, I'm going to say that a to the power of negative m can be written as 1 over a to the m. So if I have a negative exponent, I know that that's division, so I can just move it into the denominator of a fraction. And this goes both ways too. And what I mean by that is if I have 1 over a to the m, I can shuffle that around and slide the negative up there. I'm going to stop this video because of its length before moving into examples, but this is a poor point to walk away and move on to something else. I would encourage watching the second video before moving to something non-math related.